Okay, 8.1. The first thing we're going to talk about in 8.1 is the end behavior of a graph. So what you can tell, the two things that you need to look at to determine what is going to happen at either end of your graph is the leading term. So if you have a group of terms, so say your group of terms, I'll do over here, is a polynomial, and you've got 3x to the third minus 5x squared plus 7x to the fourth. Your leading term is not necessarily the first term in your list. Your leading term is always the term that has the highest exponent. So if I'm looking at this group of terms, my leading term is actually this term right here, right? Because it has the highest exponent. That makes it the leading term. That's the term that's going to tell you what the end behavior of your graph is going to do. Okay? The two things that you're going to look at are the exponent of the leading term and the sign of the leading term. If your exponent is even, that means the ends of your graph are both going to be doing the same thing. That means they're either both going to be going up or they are both going to be going down. So again, if your leading term's exponent is even, that means your end behavior of your graph is the same. Either both sides are going up or both sides are going down, and that's dependent on what the sign is. If your sign is positive and you're even, that means the end of your graphs are both sides are going to be going up. If you are negative and even, that means both ends of your graph are going to be going down. So that leading term is what determines that. It does not determine what happened in the middle of your graph going through the graph. So that's what these little squiggles mean. If your exponent of the leading term is positive, both ends are going to be going up. If your exponent is even, but your sign is negative, that means you're going to be going down. And we've already actually done some stuff like this, right? What does an x squared graph look like? It's a parabola, right? It looks like this. If it's positive x squared, they're both going up since my exponent is even, or they're going the same direction because my exponent is even, and they're both going up because it's positive. Remember, what happens if you have negative x squared? What did that graph look like? What did this negative do to that parabola? It turned it upside down. So once again, that leading term goes along with that. If you have a negative x squared, even exponent means your ends are doing the same thing. Since this one's negative, that's why the ends are both going down. So again, even exponent, your ends are the same, either both up or both down, depending on if it's positive or negative. If your exponent is odd, that means your ends are not doing the same thing. One is going up and one is going down. That is what an odd exponent means for your leading term. If you are odd exponent and you are positive, you start down and you go up. That's a positive leading term. If you are negative and your exponent is odd, you start up and go down. So remember, we've looked at x cubed graphs before. If you graph x cubed on your calculator, it looks like that. My exponent is odd. An odd exponent means your end behavior is not the same. You are going to have one up and one down. If it's a positive term, you're going to start low and go up. the x cubed graph. It flipped it upside down, right? That's what negatives do, is they reflect you across the x-axis, or in other words, flip you upside down. So it turns this graph into that. So again, since my exponent is odd, my ends are doing opposite things. They're not doing the same thing. Since it's negative, it starts at the top and goes down. So again, here's your end behavior graph. If your exponent is even, your ends are the same, either both up or both down, depending on if it's positive or negative. If your leading term has an odd exponent, that means the ends of your graph are not going to be doing the same thing. One's going to be going up and one's going to be going down, depending on if it's positive or negative. So let's look at number 1 in 8.1 and use this end behavior information. So on number 1, it says the function is f of x equals square root of 11 x cubed. I'm gonna run out of room. Plus 2x squared minus 4x plus 5. So the first thing you're going to do is find your leading term, the term that has the biggest exponent. My biggest exponent is this 3, which means this is my leading term. What does this tell me? The exponent is odd, which means the ends of my graph are going to be doing opposite things. One's going to be going up and one's going to be going down. So it's not even, it's odd, right? Because it's x to the third. Now I need to decide, well, does it start low and go high or start high and go low? Well, that all depends on what the sign is. What is the sign of this? It's positive. Doesn't matter what this is, but it's a positive number, right? There's not a negative in front of it, which means it is positive. So it is odd exponent and it's positive. So let's see, what does that mean the end behavior is going to be doing? It's odd, so it's this row. Positive means it's going to start at the bottom and go up. So if you're looking at the graph at the multiple choice, since it's odd, you can automatically take out A and C, right? Those are both even in behaviors. So you're odd, which means you're going to be going one side up, one side down. And since you're positive, you're going to start at the bottom and go up. All right, let's look at number 2. All right, this time my function is negative. And then that symbol is pi x to the 6th plus x to the 5th minus x to the 4th minus x plus 5. So again, all I'm looking for is my leading term, the term with the highest exponent. The highest exponent is 6, which means this is my leading term. So is the exponent even or odd? It is even. Which means what about your end behavior? Your end behavior is going to be the same on both sides, either both up or both down. So your end behavior is the same. Is it both going up or both going down? That all depends on the sign, which this is a negative sign. So it's negative and even. So even and negative means both sides are doing the same and they are both going down. All right, number 3, same thing. The function is negative 3.1 x to the 4th plus x to the 6th plus 0.1 x to the 7th. So remember, the leading term doesn't always mean the term that's in the front. Your leading term is the term that has the highest exponent, which is this one, x to the 7th. So let's see, what is my end behavior going to do? Is my exponent even or odd? It is an odd number, which means my ends are going to be doing something different from each other. And it is positive. So what are my ends going to be doing? Odd is this row. Positive means it starts at the bottom and goes up. So again, if you are looking at that multiple choice, odd means not A or B, right? Those are even in behavior since they're doing the same on both sides. And D is the odd behavior that starts at the bottom and goes up. Oh, there's one more of these. Two plus 1/2 x to the 4th minus 1/7 x to the 3rd. So first of all, go find your leading term, which is the term that has the highest exponent. This is this term right here. The exponent's even, which means the ends of my graph are going to be doing the same thing. And it is a positive term. So even positive means both ends are going up of your graph. Number 5. Talking about zeros. Now remember the terms that are interchangeable. The term 0 is interchangeable with X-intercept and solutions. Those are all talking about the same thing. So it wants to know, in this function, f of x equals x to the 3rd minus 8x squared plus 13x plus 6. It wants to know if 3 is a 0 of this function, which means if I replace those x's with 3's, will my answer be 0? So in other words, if x is 3, will y be 0? So let's see, if I replace my x's with 3, so I'm essentially finding f of 3. So I have 3 cubed minus 8 times 3 squared, again, replacing my x's with 3's, plus 13 times 3 plus 6. So let's do our exponents. 3 to the 3rd is 27, minus 8 times 3 squared is 9. Again, that's compare my exponents. So let's see. I'll just bring all this other stuff down. So I'm done with exponents. Now I'll go to multiplication. So I have 27 minus 72 plus 13 times 3 is 39. Bring down my plus 6 and then add and subtract that straight across. So 27 minus 72 plus 39 plus 6. So if you type that in, you do get the answer of 0, which means, yes, 3 is a 0 of that function. So let's translate to what that means on a graph. Go to your y equals and type in that function, x to the 3rd. X, to get up into your exponent, hit that, since it's not squared, you need to hit this. x to the third. Now, look how your cursor is still up in the exponent, so hit your right arrow to get out of it. X to the third minus 8x squared plus 13x plus 6. So remember what we talked about. Zeros and x-intercepts mean the same thing, which means since 3 is a 0, is a solution, it should also be an x-intercept, which means this graph, when I graph it, should cross through the x-axis at 3. So let's look at this graph. So hit graph. Look at positive 3. 1, 2, 3. So this point right there is where x equals 3. And is that an x-intercept? Yeah, this is my x-axis, and that's where it crosses the x-axis at 3. So if you're looking, you can see other zeros too. It looks like maybe 5 or around 5 is a 0. And then over here, there's another 0, but there is one at that 3 right there. So those things, they all go together. When you get to number 6, it says find the zeros of the function and then state the multiplicity of each. Before we do this particular problem, because when you're finding the zeros, you want your polynomial, you want your group of terms to be as factored out as it can. You want to see the different factors. That's how you find the zeros. So before we get into this particular problem, let's remind ourselves that the kind of factoring you're going to see on this problem is the difference of perfect squares. So if you have two perfect square terms, 25 is a perfect square, right? Since the square root of it is 5, it's a perfect square. X squared is a perfect term, since the square root of that is x. You can factor this. If I put this in its factored form or unfoiled it, these two terms have to multiply, they have to be the same, and they have to multiply to x squared. So that's x and x. These last two terms have to be the same number, and they have to multiply to 25. That's what makes it a perfect square, so I have 5 and 5. When you're factoring a difference of perfect squares, you have 1 plus and 1 minus. So x squared minus 25 in its factored form is x plus 5, x minus 5. Now, let's look at number 6. X squared minus 4 squared. So you can't find your zeros until what is inside each of your parentheses is in its complete factored form. Which means I need to factor this. That's a difference of perfect squares again. So if I factor this, x squared plus, or excuse me, x squared minus 4, x and x gives me x squared. Hang on, I'm going to stop it until that siren goes off. Okay, sorry about that. The sirens are going off. So, x and x to get x squared. What's the square root of 4? I'll use 2 and 2 for that. And remember, it's plus and minus. Well, if this one's all squared, that means each one of those factors is squared. So your zeros come from each one of these factors. What's inside your parentheses is the factor. So this right here, x plus 2 equals 0 and x minus 2 equals 0 is going to give you the two zeros or the two x-intercepts of this function. So if I solve both of those, I'll subtract 2 to get this x by itself, so x equals negative 2. Here I'll add the 2 to get that x by itself, so there x equals positive 2. So there's are your two zeros, 2 and negative 2. Now, the multiplicity comes from the exponents of your factors. So what is the exponent of each one of those factors? They are both 2, which means both of those zeros have a multiplicity of 2. So the zeros, again, come from the factors. So once you have it factored out and solved, that gives either your 2 zeros or your 2 x-intercepts. And the multiplicity is the exponent of each factor. Okay, and we'll talk about multiplicity and what that means here in a little bit. Okay, so that's number 6. Number 7 says find the zeros of the polynomial function and state the multiplicity of each again. So again, the zeros are going to come from the factors, and then the multiplicity is the exponent of each of the factors. So let's look at what our function is. F of x equals x to the 6th times x minus 1 squared times x plus 7. So first thing is we need to look inside each of these parentheses and see if there's any factoring that needs to be done to break apart our factors. So inside this parenthesis, all I have is x minus 1. There's no factor. There's nothing you can do to factor that. It is completely as simplified as it can get. It's not a difference of squares. It's not a trinomial. If it's going to be factored or need to be factored, you're going to see an x, at least an x squared inside. What about this factor? X plus 7. It can't be, it's as simple as it can get. It can't be broken into factors. So we have 3 different factors. My first factor is x. So you're going to go through your 3 different factors. X minus 1 and x plus 7 are your 3 different factors. You're going to set each of those equal to 0 to find your zeros. Set that one equal to 0, that one equal to 0, and that one equal to 0. Oops. And solve them for x. This one's already solved for x, so I'm done with that one. This one, to solve it for x, I need to add the 1 to both sides. So x equals 1. And this one, to solve for x, I need to subtract 7 from both sides. So here, x equals -7. So those are your 3 zeros. 0, 1, and -7. Now, what is the multiplicity of each of those? Well, let's see. This 0 came from right here. What is its exponent? 6. So this one's multiplicity is 6. What factor did this 0 come from? Came from this factor right here. What is its exponent? 2, which means its multiplicity is 2. And the last one, where did this 0 come from? It came from this factor right here, which means, what is its exponent? I just don't see it. If you don't see an exponent, it is automatically a 1, which means that's what its multiplicity is. Its multiplicity is 1. Now, they ask you to type this in, kind of funny. They ask you, they say the smallest zeros. So if I'm looking at my zeros, are 0, 1, and -7, that's my smallest 0, is the -7. So my smallest 0 is -7, and its multiplicity is 1. Then it says the middle 0. So who would be the middle one? This one. Its multiplicity is 6, and then my largest 0 is +1, and its multiplicity is 2. All right, number 8. Same kind of problem on number 8. So again, I hate to just keep beating this drum, but if you type that in to your graph, what do these numbers tell you? If you type this into y equals these 3 spots, 0, 1, and -7, it's going to be where the graph crosses or touches the x-axis. Those are what those zeros mean. All right, number 8. So let's look at my factors. Make sure there's no factoring that needs to be done inside this parentheses. Do you see an x squared inside any of the parentheses? No, which means your factors are completely simplified. They can't break apart into other factors. Now, the zeros only come from the separate factors that have x's. So this -6 doesn't do anything talking about zeros, right? It doesn't have an x. You can't solve it for x. So let's look at all the zeros, all the factors that have x's. This one does. So there's one of the factors. So I'll set it equal to 0. Here's another factor that has an x. So I'll set it equal to 0. And then my last factor, which is just x, I'll set it equal to 0. Let's go through and solve them. So to solve this one, I need to add the 3 to both sides. So x equals 3. This one got +1, so I'll subtract 1 from both sides. So x equals -1. And that one's already solved. X equals 0. So I have 3 zeros. 3, -1, and 0. Let's talk about their multiplicities. Where did this 3 come from? It came from this factor. So its multiplicity is 4. Where did this -1 come from? It came from this factor. So its multiplicity is 3. And where does 0 come from? It came from this factor, and its exponent is 2, which means its multiplicity is 2. Oops, sorry. All right, before we get to 9 and 10, I'm going to go over another type of factoring. And again, I'm doing this because I know not all of you took transitional algebra, and it might be a while since you have done factoring. So we're going to look at the factoring that you're going to need to know how to do factoring by grouping, which occurs when you have 4 terms in your polynomial. But there's nothing in common with all 4 of them. You're going to put them into groups. So let's just practice a factoring by grouping before we do that, before we get into those 2 problems. So let's say we have a polynomial that's x cubed minus 2x squared minus 9x plus 18. And I want to factor that by grouping because, first of all, there's 4 terms. And if I'm looking for a greatest common factor or something in common with all 4 of those terms to pull out, there's nothing that they all 4 have in common. Right? They don't all have an x, so I can't pull an x out. They don't all have a number that goes into all of them, the same number that goes into all of them, which means I'm going to put them in 2 separate groups. I'm going to group the first 2 terms together and the last 2 terms together. That's why it's called factoring by grouping. Now, I'm just looking at my first smaller group, so just these 2 terms. I do see that they have something in common. When you're pulling out x's, you want to pull out as much as you can, which means I have an x cubed here and I have an x squared here. I want to pull out as much as I can to be able to pull out of both of them. So when I'm looking at these, I can pull an x squared out of both of those. Okay, the kind of trick is you can just pull out, when you're talking about x's, you can pull out however many the lowest exponent is. right? Because I can't pull out any more than x squared from these, because that's as much as this one has. That's why I can't pull out x cubed. This one doesn't have enough to pull out x cubed. But I can take x squared out of both of them. So if I take x squared away from x cubed, that means I'll have an x left, minus, if I take x squared out of this term, I pull the x squared out, which means all that's left is 2. So I'm done with the first group. Looking at this second group, I'm going to pull something out and put in parentheses what is left again, just like I did up here. I want what's left in this parentheses to be exactly what's left in this one. So let's look at my numbers. I have a negative 9 and 18. So 9 goes into both of those, right? That's its greatest common factor. They both divide by 9. That's the biggest thing I can pull out. I also want to pull the negative out with it because look, if I pull out a negative 9 from this term, what is left? If I took the negative 9 away, all I'm left with is the x, which is what I want to be left with, right? X, because remember, you want these to match. And when I'm pulling out, the way I'm finding what's left, whatever you pull out, you divide by that to see what's left in your parentheses. So those negative 9s cancel. That's why I'm just left with the x. What do you get when you divide positive 18 by negative 9? You get a negative 2. See how those match? So let's see. My x minus 2s are now in common. So I can pull those out of this. So what is left is going to be pulling out this x minus 2. So just like I've divided by negative 9, whatever I pull out that's in common, you divide by it. So this x minus 2 cancels that one in both spots. So let's see. What is left in the second parentheses? This x squared minus 9. Now, we've run into something else. This one I can't factor anymore. It's done. But look what's inside this parentheses. It's got an x squared and a minus 9. Those are both perfect squares, which means now that one is a difference of perfect squares. So I have x minus 2 that'll just drop down. But this one will factor, again, x and x for x squared. What's the perfect square factor of 9? It would be 3 and 3. One's a plus and one's a minus since it's a difference of squares. So this polynomial all the way factored is this. X minus 2, x plus 3, x minus 3. So let's look at number 9 and number 10. If you need a couple more of these groupings, we're going to see them on 9 and 10. The actual new work on this problem is not hard because we just need to get to where we have these 3 factors because that's where your zeros are going to come from. So the hard part is actually the factoring by grouping. All right, find the zeros of the function and their multiplicities. I've got x to the third minus 4x squared minus x plus 4. So it's so different than that last one where we were finding zeros because the last one or two, my function was already in its factored form, right? Inside, I already had my factors separated out for me. The x minus 3, the x plus 1, the x. Same here. Had my factors already separated out for me. X minus 1, x plus 7, x. The difference on number 9 is it's not in factored form. I don't have the factors in their nice, neat parentheses already separated out for me. I have to do that. which is the factoring by grouping. So once again, you've got 4 terms with no greatest common factor, so I'm going to put them in groups of 2. Looking at my first group, I've got an x cubed and an x squared. So how much x can I pull out? Well, whatever the smallest exponent is, which is x squared. So I didn't do this on that last one, but remember what I said. What do you do with what you pull out? You divide by it. Whatever you pulled it out of, you divide it by what you pulled out. So if I take an x squared out of x cubed, I'm left with x minus. If I pull the x squared out here, all I'm left with is 4. Now, remember when we're factoring by grouping, you want your second parentheses to match your first. It almost does already, right? X minus 4, but this one says negative x plus 4. And also, when I'm looking at this second group, I don't even see anything in common to pull out. So then I have to decide, I have to pull something out because that's part of grouping. If you have to pull something out of that second group, so if there's not anything in common, you're either going to pull out a positive 1 or a negative 1, depending on whether or not you need to change your signs. Do these signs need to change in order to match these signs? Well, they do, because I have a negative x, but I need a positive x. I've got a positive 4, but I need a negative 4, which means my signs need to change. And you change signs by pulling out a negative 1, right? Because if you divide those by negative 1s, their signs will change, just like I want them to. So let's see, a negative over a negative turns that to positive x. Positive 4 over negative 1 is negative 4. So now, look, your parentheses are the same. So now you can pull out that x minus 4 from both of those areas. And if that's what I pull out, that's what I divide by. So those cancel. So what's left for my second parentheses? X squared and minus 1. So I still have an x squared inside my parentheses. That is telling me that my factoring is not all the way done. This one's done, right? There's no x squared inside of here. But this one, again, it's a difference of perfect squares. 1 is a perfect square because 1 times 1 is 1, right? 1 is a perfect square. So I've got to still factor this. X and x for x squared. 1 and 1 multiplies to get 1. 1 plus and 1 minus. So there are your factors. So if you'll notice, now your problem, what we've gotten it to anyway, now resembles what your last problems were. It's got the parentheses with the factors there for you now. So now you can find your zeros from that, which is actually the easiest part. What are your factors? So here, this one is x minus 4, so I'll set it equal to 0. Here, x plus 1, set it equal to 0. And x minus 1 equals 0, and then solve them. So if you add 4 to both sides here, you end up with x equals 4. You subtract 1 from both sides here to get rid of that plus 1. You have x equals negative 1. And this last one, if you add 1 to both sides here, you get x equals 1. So your 3 zeros are 4, negative 1, and positive 1. What is the multiplicity of each of those? They all have the same multiplicity. Do any of them have exponents above their factors? No, then all their multiplicities are 1. If, at the beginning of this, if you wanted to remember, what do zeros tell me? They tell me where the graph crosses the x-axis. Put that in your y equals. So x to the third. I'm going to arrow to get out of the exponent, right? X to the third and then arrow out. Then minus 4x squared. Oh, shoot, I missed it. X to the third minus 4x squared minus x plus 4. Graph that. So if you'll notice, what does the function do? It crosses through at -1, +1, and +4, which is what your zeros told you. It crossed through the x-axis at those 3 spots, okay? Another way to do this, there is a zero function in your calculator. It doesn't tell you the multiplicity, but it would definitely help you with a problem like this. If you go to second calc, look what number 2 is. 0. So go down to number 2. I want you to find the zeros. Again, it asks me all this left bound and right bound stuff. So to find this first 0, the one that's farthest to the left, make your cursor be on the left of it, right? That's what left bound means, is make your cursor go to the left side of it. So I'm going to hit my left cursor until I get to the left side of it, which I am now. So I'll hit enter. Now I'm going to hit my right cursor, my right arrow until I get to the right side of that 0. So see, I passed through it, right? I passed through the x-axis, which is the 0. Hit enter again twice. Look at what your 0 is, -1. If I wanted to find this next 0, which is or let's go over here and find this one. You can do it to all 3 of them. I'm going to go over here to find this one. So again, second calc, I want to find a 0, so I'm going to go down to 2, hit enter. So I need to go all the way to the left. I'm going to hit my right arrow. I just passed through that, so I need to go, I want to be to the left and right of this 0, right? This X-intercept right here. So now I'm on the left side of it, and then I'll pass through it and go to the right side of it. So I'm on the left side, so I'll hit enter, hit my right arrow. I pass through to the other side of it, so I'll hit enter again twice. Look what your X is. 4. It found that 0. So you can also use that method. Okay, it doesn't tell you the multiplicities, but it does tell you the zeros. Let's look at number 10. I'm going to work it out like this because it wants the multiplicities also. This is the last one of these. Another. Cubed minus x squared minus 50x plus 25. Again, I gotta see all this. I gotta see the factors, right? I can't find zeros until I have factors. Because where do the zeros come from? They come from setting the factors equal to 0. So I've got to see the factors separated out into their own nice little neat parentheses. So I've got to factor this. So I'm going to put them in groups of 2. Out of this first group, all I have in common is that x squared. So if I take x squared out of both of these, if I took x squared out of here, I still have the 2. I pulled x squared out, but I had x cubed, so I still have an x. Minus, what's left here? It's not 0. What is x squared over? If you divide it by itself, you are left with 1. Looking at my second group. Now remember, you want this parentheses to be 2x minus 1, so it'll match the first one. So let's see, what goes into 50 and 25? 25 does, right? So I'm going to pull out some kind of 25. I just need to decide if I need to pull this negative out with it. So if I pull out positive 25, what am I going to be left with here? What do you get if you divide negative 50 by positive 25? You get negative 2x. I need positive 2x, which means all that tells me is I need to just pull a negative out with that 25 so I can change my signs to be what I want them to be. If I divide negative 50 by negative 25, it gives me positive 2x. Positive 25 divided by negative 25 is negative 1. Now my parentheses match. So I've got 2x minus 1 that I can pull out. What's left is just these two things right here are always going to be your second parentheses. So x squared minus 25. So this one's done. I don't have any exponents inside this factor, so that one's good. But what about this one? Again, perfect squares. So I need to refactor or factor this one some more. X and x for x squared. 5 and 5 for 25. 1's a positive. 1's a negative. Let's drop this one down. So now I have nice, neat factors. That's where your zeros come from. What are your three factors that you see? You see 2x minus 1. So I'll set it equal to 0. X plus 5. I'll set it equal to 0. And x minus 5. I'll set it equal to 0. Solving this one, I need to get rid of minus 1, so I will plus 1. So 2x equals 1. Still got to work on it, right? I still have a number with the x, so I'll divide it by 2 to get x equals 1/2. So there's one of the zeros. Here, subtract the 5. Get rid of the plus 5, so x equals negative 5. And this last one, get rid of minus 5 with plus 5. So x equals positive 5. So your three zeros are negative 5, positive 5, and positive 1/2. Now, where do I find the multiplicities of each of these? Well, the multiplicities come from the exponents of the factors. They all have an exponent of 1. Okay, for the last two problems, let's talk about the multiplicity rules. What does the multiplicity tell you? Right? Sometimes there's an even multiplicity, sometimes there's an odd multiplicity. What that tells you is what is happening at the x-intercept. Because you are an x-intercept, whether you pass through the x-axis or sometimes you just come to the x-axis, you touch it, and then you go back the other way. For instance, you have a graph. There's two different kinds of x-intercepts. This graph, this red squiggle that I just drew, has three x-intercepts. It's got one here, it's got one here, and it's got one here. Sometimes your x-intercept is at a point where your graph goes straight through and crosses the x-axis, which is what happens here. It's also what happens here, right? It crosses the x-axis here. So look at this x-intercept. It touches the x-axis and then goes back the other way. It doesn't cross all the way through it. It just touches it and goes back the other way. It is an x-intercept. It just doesn't cross through the x-axis. It's called being tangent to the x-axis, which just means it goes and it touches the x and goes back the other way. It doesn't cross all the way through it. That's what our multiplicity tells us. If your multiplicity, which remember, your multiplicity is the exponent of your factor. Right? Some factors look like this. These are what your multiplicities are, right? That's how you find your multiplicities, are the exponents of your factors. If your exponent is odd, so you have an odd multiplicity, that tells you at this 0, you are going to cross the x-axis. So this right here, the 0 would come from this factor, which means I would set this equal to 0. My 0 would end up being -1. The multiplicity would be 3, which means at that x-intercept, the graph crosses all the way through the x-axis. If your multiplicity is even, that means you are tangent to the x-axis, which means you're still an x-intercept, but you don't cross the x, you touch it and go back. So, looking at number 11. Says if p of x equals x minus 5 to the 4th, x plus 2 to the 3rd. Then the graph of the function crosses the x-axis at 5, 0. So, and this is a true-false kind of statement. So let's see, right here is the key word. It says it crosses the x-axis at 5, 0. So the 0 here, the x-intercept it's saying is 5. Which one of these factors did that come from? Did it come from this factor, right? If this is the factor, I'd have to add the 5 to both sides, right? To get x equals 5, which is what this says right here. So this x-intercept came from this factor, not this one. So we just totally ignore that, right? It has nothing to do with what this problem is saying. What is the multiplicity at this x-intercept? It is even. Because the exponent is even. What does even multiplicity tell you? It tells you that your graph, your x-intercept is tangent to the x-axis at that point. It doesn't cross. So this would be false. This 0 would be tangent to the x-axis and not cross it because the exponent is even. And number 12. Last one. If p of x equals x minus 8 to the 7th, x plus 5 to the 10th, it's saying that p of x is tangent to the x-axis at -5, 0. So where did that x-intercept come from? This is the x-intercept. At -5, which factor did that come from? Came from this factor, right? The x plus 5 factor gives me a -5, 0. So I totally ignore that. What is the multiplicity of this 0? It's even. And what does even multiplicity tell me? Even multiplicity tells me it is tangent at -5, 0. It is tangent at that x-axis, at that x-intercept, which means this is a true statement. It is tangent because the multiplicity of this 0 is even. All right, I know that's a lot, so if y'all have questions next week on this, I'll be happy to answer them at the beginning of class on Monday.